Welcome, and thank you for joining today's session and our webinar around Red Hat AMQ and common deployment patterns. My name is Andrew Tenalia. I lead our hybrid cloud practice for Lighthouse, which is a converged company. Before I turn it over to Ritesh Patni to lead today's session, I'm just going to spend a few minutes telling you about Lighthouse and Converge. Lighthouse is a leading IT solutions provider, regionally focused in the Northeast U.S., and we've been serving our clients for the past 20 years. In December 2018, we were acquired by Converge Technology Solutions. Converge is a leading North American hybrid IT provider, providing hardware, software, and managed services to our clients. Now, we have a portfolio of companies, and with those portfolio of companies, have a vast array and deep technical skills and maintain the highest level of certifications with key vendors. One of those key vendors is Red Hat. Lighthouse and now Converge are Apex Red Hat partners. So what that means is Red Hat actually selected us to be part of their premier partnership program. Obviously, that means we need to maintain a certain level of accreditations and certifications and deep technical skills. As most of you probably know, Red Hat's now part of IBM, who's actually Converge's largest partner. Today, we're here to tell you about one of those solutions from Red Hat that we've implemented for some of our key clients around their messaging and integration needs, and that's Red Hat AMQ. So here's our portfolio of companies. We're focused on cognitive, cloud, cybersecurity, digital infrastructure, digital transformation, and talent acquisition. As you can see, we have a North American footprint with sister companies across the I guess, North America with Canada and the United States. And how we help our clients today is through cloud services, including disaster recovery and redundancy centers, reselling hardware and software solutions, again, as I mentioned, with some of our key partners like Red Hat, who's sponsoring today's session and who will be telling you a little bit about some of their key solutions around integration and messaging, and of course, managed services, taking that workload off of our clients' plate and bringing those skills in-house. So without further ado, I'm going to turn it over to Ritesh Patni to take this through today's session. You'll be hearing about Red Hat AMQ, as I mentioned. We're going to give you an overview of the technology, some of the components, and again, probably what you guys are most interested in hearing today is common deployment patterns and use cases, and how Lighthouse, a converged company, has helped customers implement Red Hat AMQ. Ritesh, with that, I'll turn it over to you. Thanks very much.
Today, today's agenda is we're gonna cover the Red Hat AMQ overview, AMQ protocols, what are the different protocols we are using it, AMQ Broker Overview on a high level, AMQ Interconnect Features, common deployment patterns, and if the time permits, we're going to see AMQ console with how you can go and browse the queues, look at the queue depth, any attributes, few JMX operations which can be used from the pure Java. So let's talk about AMQ as a whole. So AMQ is a message-oriented middleware solution. It's basically helping in integrating different applications in a reliable and skillful way. AMQ is a lightweight, flexible, and reliable messages platform that simplify both the integration of application components as well as the workload scale. It's AMQ focuses on the international standard protocols like AMQP and MQTT, Storm, which virtually allows any application to connect. AMQ as a whole, it's a family of a different product. AMQ comprised of AMQ client, which include Ruby, JMS 2.0, C++, .NET support. AMQ has interconnect routers, which is basically if we want to for the fast performance when there is no persistences involved. AMQ also has an AMQ stream, which is based on Kafka, which is Apache Kafka. And then AMQ also has AMQ Online, which is managed and sets up the messages from the cloud. So we talk about all these different components when we talk about in the future slide. So AMQ, here you can see what each of these vibrant communities had distributed to the AMQ product. So based on the upstream projects, Apache ActiveMQ and Apache Cupid, JBoss AMQ integrates the enterprise application by providing a standard-based platform for application component and a subsystem to communicate in a loosely coupled manner, regardless of the language and the platform. So AMQ Broker is basically based on Apache ActiveMQ Artemis. AMQ Client, they are using Apache Cupid. AMQ Stream, Apache Kafka, which is a leading real-time distribution messaging platform for building data pipeline and stream applications. Then we had EMAS. It is EMAS platform which focus on scalability and the performance. AMQ Online is based on EMAS. HAT AMO is the real-time web console for interacting with the broker and the interconnect routers. So HAT AMO is inbuilt in AMQ Broker, whereas with the latest version of AMQ 7.4, routers has their own HAT AMO. It is not inbuilt with Broker. Strimzy provide a way to run Apache Kafka on a cluster on a various deployment configurations. So these are the different communities which is contributing to Red Hat AMQ as a product. So let's talk about what are the different products. I already said, like we have AMQ Broker. AMQ Broker is a traditional GMS 2.0 compiled broker queues and topics, which has a different messaging strategy like store and forward. It is a pure Java multi-protocol message broker. It's built on efficient asynchronous core with the fast native journals for messaging persistence and the option to share nothing, state replication, or high availability. Interconnect router is a brokerless routing. Its client has to, in this way, the client has to be smart that they know that there is no broker on the end, and they have to hold the messages for now. So we usually see interconnect routers which are getting used with broker side by side, which increase the high speed performance and flexibility for routers, and you get the persistence and the safety for the broker. So when we use interconnect routers and broker together, broker in that case act as a client which can consume in terms, process the message, and route this if there is no other consumer. Streams, which is like AMQ Streams, which is PubSub, reliable. It's based on Apache Kafka. So we often get the question is when to use AMQ Broker or AMQ Stream. The best way to put it is, do you care of the individual messages or do you care of looking at a group of messages together? If you're looking for an individual message, then broker, like for example, auto management, sending notification. But if you're looking for the group of messages, then stream, like log aggregation, website analytics, example. AMQ Online, which is the messaging as a service, is to provision messages when and where you need. Basically, it is good for the developer because they themselves go on the dashboard, create the queues, create the topics, basically, which is called addresses. And administrator can also configure a cloud-native multi-tenant messaging service in the cloud or on the premises. So let's talk about AMQ protocols, different kind of protocols which AMQ supports. So what is a problem when we start using some proprietary messaging protocol? It is difficult to integrate. It has a lot of restrictions, a lot of locking. So you have a limited to whatever you want to use. If you want to use, you have to subscribe. You know, and the difficult to integrate with the different protocols is really a challenging. So AMQ has a wide range of protocols which they support, and the most used protocol is Advanced Messaging Queue Protocol, which is AMQP. It is an open standard for passing business messages between application and organization. It connects systems, feed business processes with the information they need. So AMQP specifications is published by OSS, I think in beginning October 2011, and provided under the OSS copyrights and subject to OSS usage. It's allowed and released as an ISO and IEC international standard, I think in April 2014. So AMQP, it is effective, reliable, flexible, and the broker model independent. We have another protocol which is called MQTT, which is Message Queuing Telemetry Transport. It is useful for connection with the remote location when and where a small code footprint is required, and the network bandwidth at a rate of the premium. For example, it is being used in the sensor communication to the broker via satellite link, and is also very ideal for mobile application because it is very small, low power usage, and minimized data packets. And it is really effective, efficient in distribution of information to one or more receivers. Other protocols which AMQ supports are OpenWire, Core, HornetQ, Storm, Kafka for AMQ stream. Okay, so let's talk about AMQ Broker, which is also stated as a high performance messaging broker. So AMQ Broker is a high performance messaging implementation based on ActiveMQ RMS. It's used as asynchronous journals for fast messaging persistence and support the multiple language protocols and platforms. It is a pure Java high performance and multi-protocol broker. It provides clustering. It provides the shared HA by using the SAN or replication, which is share nothing. Specialized queuing behavior, message persistence, and manageability. It is different messaging style, like a publish, pops up, point to point, store and forward, different protocols, and the client language it support, like JMS, C++, .NET, Python, Node.js, with the different protocols as we already saw. So this is the normal address model of AMQ. So AMQ so it works on addresses. So addresses, which is in turn create the queues, but addresses are anycast and multicast. Anycast is more like one-to-one, and multicast is more like one-to-many. So in this example, you can see a sender is putting a message to the address called address.foo, and your receiver is picking the message from an address called address.foo. But in turn, AMQ create an internal queue, which is not seen to sender and consumer, but they connect to the address. Same way for the multicast, where you have one-to-many, sender is sending a message to topic.foo, and the receiver is also listening on the topic or on the address, which is called topic.foo. But internally, they are AMQ creating a queue for them, and then each receiver is actually attached to the assigned queue. AMQ Broker. So we see that in terms of persistence, what AMQ Broker usually do. So under normal operation, everything is stored in the memory. Message arrives over the wire, they kept into memory and the forward to consumers. Persistent message and transaction and so on are written to disk for the sole purpose of recovery from memory if the broker fails. So it's a default method. Journals are used as a default method. So most of these configurations are part of the broker.xml file. When one of the general files, so how that works is that as a client performs various broker operations, records are appended to general. And when one of the general file is full, the broker moves to the next general file. Paging, if the broker ran out of memory, the broker start paging to a different area. That area can be defined into that area can be like a database or a file that can be handled into a broker.xml. Same way for the large messages, broker do support a large message with even when running into a limited memory resource. We can configure AMQ Broker to store these large messages into the file or into a database. You can go into broker.xml file and you can change the settings there. So this is the deployment options with the broker when you have a multiple brokers. You know what scenario you need a multiple broker, like when you have to achieve high availability, when you have too many connections to one broker, you have too many queues to one broker, you have very high message throughput, or you want message system different geographical location. So how you achieve that? So basically, by using a clustering. So the cluster consists of multiple broker instances that have been grouped together. So broker cluster enhance the performance by distributing the message processing load across the multiple brokers. So it's not that only all the loads are going to a one broker. It's been distributed across. In addition, the broker cluster can minimize the downsize through the HA. So if you're using a havability, it minimizes the downsize for the broker. You can connect the broker together in many different cluster topology. Within the cluster, each active broker manages its own messages and handles its own connection. You can also balance client connection across the cluster and redistribute messages to avoid the cluster starvation. So basically, so if you have a multiple brokers, each live broker or each broker communicate to another broker by using different technology, like by using UDP, multicast, or JGroup. I'll show you with an example, how we can configure this in the following slide. And the best part about the cluster is that your producer can connect to one broker and the consumer can listen to another broker. Internally, the broker sees that if the message is if the queue is reside on broker A and the consumer is trying to pick the message from broker C, the messages flows internally as all the brokers knows each other. They discover each other in the cluster. So this is on a high level. It says that you have a client on the side, you have 4 brokers, and you have a broker cluster. And then you have a server discovery where you can broadcast himself in the group. And it basically messages arriving on cluster are balanced and distributed node to spread the loads. The settings are done automatically between the brokers and can be configured into broker.xml file. So server discovery is basically how clients and broker find each other. So in AMQ, you can do the server discovery dynamically or with a fixed config. So dynamically by using the JGroup or UDP. JGroup is for base TCP. Broadcast groups mean by which a server broadcast connection over the network. Server-side messaging and load balancing if the cluster connections are defined. So yes. So coming back to server-side messaging load balancing. So if the cluster connections are defined between nodes and cluster, then the broker will load balancing messages arriving at a particular node from a client. So, and there's a different topology here where we use cementing cluster, where each node in the cluster is connected to every other node in the cluster. This is a highly used topology in the clustering. So in other words, like every node in the cluster is not more than one hop away from every other node. Chain cluster, where each node in the cluster is not connected to every node in the cluster directly. It basically, they are chained together to the previous and the next node in the chain. So this is a slide where we are just showing you high-level broker configuration, broker.xml file. This is, you're achieving a clustering by using the JGroups. If you see here, we are defining the jgroup.xml file. You have to define the broadcast group, what is the name of the broadcast groups, and what connector it is being connected to. This is the connector. Then you have to provide the discovery group and the cluster connections. Note that all the broker in the cluster has to use the same username password so that they can connect to each other. High availability and failover. So what HA ability for a system to continue functioning after the failure of one or more of the servers. So failover is basically, it's migrate from one server to another in an event of the server, failure, so the client application can continue to run. In AMQ, there are two types of, failover HA. One is called shared file system journals, other is called replication. So a shared file system is where both live and backup servers share the same entire data directory using a shared file system. And then in the replication, live and the backup server do not share the same data directory. They all data synchronization is done over the network. We'll cover more in detail in the next slides. So let's talk about the shared storage. It works on the file log. So live and the backup server stores the messaging data in a single directory or on the shared directory, which is typically a storage area network or a SAN. If the live broker fails, the backup broker loads the messaging data from the shared library and takes over the failed live broker. In most cases, we should use the shared storage instead of replication because shared storage does not replicate data over the network. So it typically provides a better performance than the replication. And also, I'll show you in the further slide, but shared storage also provides the network isolation, which is also called the split brain. So in this case, if the live servers goes down, it activates the backup server. As soon as the live server goes down, it releases the log. And as soon as it releases the log, the backup server keep polling for the log, and they see that log is available. It takes the log and activates it. This is an example where we don't have a shared storage. You have a live broker and the backup broker. So live broker has the server log on its journal, on its own individual storage. It has the general data which is calculating and replicating. And then if anything goes wrong to the live, the backup becomes live and copying the whole general files over the network. This is a little bit expensive because copying might take a couple of times, couple of minutes, or maybe a few minutes, and then that's a time where maybe few that's a time where the backup server takes time to actually come up. This is basically a situation where this is called network isolation, and usually when you're using a application, you need to be very much aware of understand how it occurs and how you can avoid it. So network isolation can happen if a live broker and its backup broker become live at the same time. So basically, so network isolation it happens when live broker loses the connection, and the backup broker saw that the live server is not available, bring himself up, as well as soon as the live server restore the connection and also become the live. So both the live broker and the backup can become active at the same time. So this is basically called a split brain, and if the backup broker can still connect to more than half of the live broker in the cluster, it says that okay, it seems that I have to become active, and then become active. In this case, each broker has completely different journals. So to avoid the split brain or network isolation, it is recommended that you use the shared storage and at least a 3 live backup pair in the cluster. Next topic we're going to cover is AMQ Interconnect Routers. This is it is flexible and scalable direct messaging delivery. AMQ Interconnect Routers are the lightweight AMQ message routers that is used to build large message networks. The routers act as a bridge between the different AMQ-enabled endpoints. As of now, AMQ Interconnect Routers only supports any AMQP-enabled services. AMQ Interconnect Routers are based on the dispatch routers, from the Apache Cupid. It supports deployment in topology for multiple routers with the multiple paths, providing easy scalability, which can be distributed more simply than a traditional broker. AMQ Interconnect Routers is a high-speed, low-latency message routers rely and transfer messages through the network with a very high performance, as there is no persistence. So the producer and the consumer can connect to the interconnect routers directly without broker coming into a picture. Interconnect routers, as you can see, is a high-performance direct messaging, flexible, scalable. It provides intelligent message routing where you can provide some filtering, the content-based filtering, lightweight and simple configurations on the in the config file you need to provide like where the messages are going and where the messages are coming from. Some of the high-level overview is interconnect router can be one-to-one or one-to-many. It offers the shortest path routing with redundancy. As of now, it's only available on RHEL. It is asynchronous and event-driven architecture. It is implemented in C and embedded Python. It connects clients and broker into a internet scalable messaging network with uniform addressing, support the very high performance direct messaging. All right, these are the different components of interconnect routers. We have a listeners, we have connectors, link route, and auto link. Listeners provide the listeners that accept the client connections from outside. Connectors to configure to create the outbound connections to messaging broker or any AMQP service provider. Link routers, link router, you can represent that as a private messaging path between the sender and receiver, in which the router passes the messages between the endpoints. So you can think of as a virtual connection or tunnel that travels from sender through the router network to the receiver. Autolink routes uses the internal autolink to connect to the queues on the broker, and it is basically, you can have bidirectional in and out. So let's say this. So you have a client and interconnect routers, as I said, it is as of now only support AMQP 1.0 protocol. It is written in C and runs on Rail. It is a single contract. Interconnect router doesn't have, it is a brokerless messaging where you don't need a broker because if the messages doesn't need to be persistent, you don't need a broker behind the interconnect router. Interconnect routers does not take ownership of a message because it does not store the message, so the ownership has to be given back to the producer and the consumer. Same, you have a listeners and you have interconnect router listens and interconnect and routers connect to different AMQ providers. Okay, so some of the features of interconnect routers. Anycast, which is, it balances traffic across the route to a different receiver. The faster receiver get more messages. Then you have multicast, which is message get duplicated to router. Each consumer receive one messages. Then you have message route, which when the delivery arrives on an incoming message router link, the router extracts the address from the delivery message to field and look the address up in the routing table. The lookup result in 0 or more routing link on the which the message shall be, resent. Link route is basically uses the same routing table that messages routing uses. It basically sees that I have to go from point A to point B. As I say, link route is more like a dedicated route between the sender and receiver, more like a tunnel or VPN. With the previous slide, same thing. We have the different delivery patterns. We have multicast and anycast. We have link route. Anycast allows the multiple receiver to use the same address, and the fastest receiver get more messages. Then we have another routing pattern, cross closures, where allow multiple receivers use the same addresses. It is anycast. One receiver will get the messages, and it's multicast, another routing pattern which allows the multiple receiver to use the same addresses. Each consumer receive one message get duplicated to route. This is very high-level diagram where you can see that clients are connected to a different interconnect routers, and then routers are connected to the broker. Some of the time, routers are connected to each other. You don't have to go to the broker if you don't persist the message. Uh, a, a difference between AMQ broker and interconnect routers. So this is on a high level is what is the runtime for the AMQ broker is more JVM, interconnect router is Linux. Protocols, AMQ routers only support AMQP, whereas AMQ broker support MQTT, Storm, AMQP, HornetQ, Open Wire Core. In terms of ownership of message, AMQ broker has the ownership of message, where the AMQ router does not take ownership of message. High availability provided by clustering, whereas in AMQ interconnect router it's provided by redundant topology. When should we use it? AMQ router is basically used when you don't need a store and forward, when you don't need a clustering, backing stores are not needed. You don't need any hybrid direct broker deployment. Basically, most of the cases where you want to achieve the high performance and you don't want to store the messages to the broker. So let's see some of the AMQ common deployment patterns. Deploying, so this is the first pattern which say router pair behind load balancer. So you are deploying the two routers behind the load balancer, which provide the high availability and increased scalability for this single data center deployment. So you have a clients which are connecting to a load balancer, and then load balancer is distributing the messages to the routers, which in turn sending the message to the different broker. So endpoints make their connection to the known URL. Basically, clients are which is supported by a load balancer. So the load balancer spread the incoming connections among the routers so that the connections and the messages loads is distributed. And then in this case, if one of the routers fails, load balancer detects that and send all the connections and the messages to one router until the failed routers recover back. This is another deployment architecture where the router network is providing a layer of protection and isolation between the client in the outside world and the broker backing as the enterprise application. So it's basically where clients are connected to a load balancer, and then you have the external routers and then the internal routers. So load balancer are only connected to external routers, and the external routers are connected to internal routers and then to the broker. So, it's an internal routers connection between the enterprise and the DMZ always established from the enterprise to the DMZ for the security. So it's basically, in this case, the benefit is that, for the security, for the connection between the external routers to the load balancer and to the internal routers to the external routers. So your deployment might use a certificate. For internal security, you can use a different certificate, and for the external, you can use a different certificate. So this is you can use in a more complex topology in the deployment of AMQ components that span in the multiple locations. So the same for instance, the router pair behind the load balance can be stored into two different locations or 4 different locations, and then you have the backbone of routers, which is routers in the middle, which can connect to all the interconnect routers. Another is topology, or another architecture is called the connection aggregation, where your clients are connected to a routers, and then routers connected to a different routers, and then connected to a broker. So application may want to use many connections in this case, and then, but AMQ Broker, AMQP Broker can allow specific limited number of connections. So in this case, clients are connecting to a router with many connections, but router is connected to broker with one connection. So router will route traffic between the client and the broker. Broker will not underload from handling the many separate clients. So this is a connection separations, which is client need to connect to a different AMQP broker. So maintains many connection, add complexity. So it's in a reverse way where routers are playing a role which can be connected to a different broker, but client is making one connection to the router, and routers are connecting to a broker in a different. So it can also use as a shield your application from AMQP infrastructure. This is called broker isolation, reverse proxy. So AMQ Broker is running in network which does not allow incoming connections, only the outgoing. So clients want to connect to a broker from outside. So in this case, we use two interconnect routers. Router A, which is on the left-hand side, will run in the outside network and work as a listener. Router B will run in the protected network and open outgoing connection to the broker as well as to the router A. So client will connect to router A and send and receive messages to and from the broker. This is example of one of our clients, which we recently work with. This is the AMQ Broker, which is in cluster and HA. We have 3 different VMs, and on each VM we have a master pair and the slave. But master on in this example, if you see a VM host 1, we have AMQP primary, and its backup is on the VM host 2. Same way on the VM host 2, we have AMQP2 primary, which his backup is on VM host 3. And then we are achieving the clustering by using the JGroup channels, and then we are using replication. There's no shared storage. This is an example which talks about putting the interconnect routers on top of the broker. So the clients are connecting to interconnect routers, and interconnect routers are connected to broker. In some of the scenarios, clients are connected to interconnect routers, and interconnect routers are directly connected to consumers. So this is very high level where we have defined that the clients are connecting to all the routers, which is behind the load balancer. So the load balancer is distributing the traffic to all the different routers, and then in turn, if the message needs to be persistent, is going into a database. Otherwise, it's going directly to the out routers, and the out routers is and the clients are connected to out routers. Okay, so we'll see some of the AMQ console. As I mentioned, AMQ console 7.3 because there's a few changes on AMQ console 7.4. Basically, AMQ Broker 7.4 does not include interconnect routers. Interconnect routers now have their own HAT AMO, but when we designed the slides, we were using AMQ console 7.3. So you can see interconnect routers are part of 7.3. AMQ routers AMQ console is a web-based console including the AMQ broker installation. It's basically you can monitor the monitor the broker, routers, client. You can see the queues, connections, addresses, etc. This is the overview of overview of the web console. This is address administration, where you can actually create the addresses, define the routing type, whether the address should be multicast or anycast. Here you can go and see the queues, queue depth, and then in the diagram you can go and see, if the brokers are in the cluster, it can show that which broker is a live broker and which broker is the slave broker. And all the green one which you are seeing is the live broker, and all the red one is its corresponding backup broker, which is in a different VMs. This is more the interconnect routers attribute, which talks about this is my router A, which has these attributes. This is connecting to the broker, and how, and then what are the different attributes it has. This is basically a topology where I have a client A and a client A putting the messages onto a specific routers, and how routers are linked together by using link route or auto link, and then consumers are listening to a different routers and how that is. So with that, I just want to quickly show you the console. Let me just see if my so my brokers are running. So I have okay. So if you see this is AMQ management console, where you can go and see all the information, generals. This is the broker.xml file. Like, these are the addresses which are defined here. These are the generals, where the general directories are, and you can see the large messages here too. Large messages directory right there. So this is most of the information are running from the broker.xml file. Then you can go and see. Right now, I do not have any clients connected to it, so you can see no producer and consumer here. But you can see all the addresses which are defined by me, and then what addresses are what type, routing type is multicast and anycast. Then these are all the different queues, which is nothing but addresses. See this. And then it defines what are the message count, how many messages are on this queue. As I shown in the slide diagram, this diagram shows that which one is your live server, and then what are the queues connecting to the live servers. If you add the slave broker here, I'm running in a HA. I have only one slave connected right now, so it's showing me that you have a slave which is running on the same machine. So it's in localhost 616.17 port. My slave is running, and my live broker is running here. This is more. These are all the JMX operation. If you want to call the operations which are right here, you can actually go. You can, like for instance, if you want to add a user, you can actually add a user from here, or you can call this and pass the parameter, and you can add a user. So this is more like a JMX endpoint which you can use to. These are the different attributes, as I mentioned. Each queues when you look into each queues has its own operation which you can do from the admin console as well as by using a JMX. So this is all the different operations you can perform on the queue. If you see, these are all different operations which you can perform. Like if you want to delete all the messages, so you can see just so if you want to add a user here, add users. So on the queues, see, this is what you can do is I can send a message right here on the address, and on the queue, what operation I can do is I can browse it, I can count the messages, I can list all the messages counters, I can move the messages. If I have to remove all the messages, I can remove all the messages. Okay, so back to the presentation. Yeah. So back to the presentation. So that's all we have for the presentation. I'll go back to the last slide. So we have thank you all for joining, first of all, and we have the upcoming sessions. We have the upcoming session for the AMQ stream and AMQ online. The invite will be sent, and see you soon. And if you have any questions or any feedback, please reach out to me. My email address is below. And thank you so much again for joining.